Hi, my name's Dan, and this video is one in a short series of videos that I'm doing about the creation of registers, which are a component in CPUs. So the large scheme that I'm on is a whole set of videos using this digital simulation software called DigitalWorks, which goes from the fundamentals of basic logic gates all the way through to the creation of a simple 4-bit CPU. This short set is about registers, as I said. If you don't know what one of those is, you need to watch the previous videos. There is a roadmap of where we're going in the grander scheme of things in the description down below. There's also a link to where you can get hold of this software, which is free, DigitalWorks. And we're doing this in a simulated way because it's cheaper than doing it in a hardware way, and also more visual, so it's easier to learn what's going on in this. So where we're up to is that we've been talking about registers, we've been talking about the bus, which is the way that they communicate with each other, and talking about a specific problem that we have with the hardware, which is that we can only have one component which sees the bus as its output at once, because of a limitation in digital electronics, which is that you can't connect the output of one gate to the output of another and have it work reliably as to what you want, because they're both of them trying to force their idea of what that data should be. So we're going to introduce a new component, a new gate, which will show this, or which is used for specifically for this purpose, which is called a tri-state buffer. So along the set of different gates that are available in DigitalWorks, you've got the standard ones along here, but you're missing a vanilla buffer. But there is this, it calls it a tri-state device. It's often called a tri-state buffer because it is in fact a buffer, because it just allows pass-through of data, but it has something extra in it. So let's just click off it. It's got an input on the left as normal. It's got an output on the right, and the output will be the same as the input. However, it has an extra line which is coming in from below, and this is an enable line. And actually, unlike doing an enable using an AND gate, which is a kind of normal way of doing it in hardware, when this gate is not enabled, then it does not see this as an output. It actually is disconnected from the output, which means that we can have several things going to the same place. As long as we only connect up, enable one of them at once, then we're fine. Let's quickly demonstrate this with a little circuit, and then maybe show it in a broader context with the bus. So let's have another one of these, and I'm going to connect the outputs together, which is something that if I try to do with any other gate in DigitalWorks, it would give me a complaint and not allow it. And I'm going to connect that through to an LED so we can see the output there. And I'm going to put interactive inputs on the input. But I also want interactive inputs for the enable. So this is basically switching. So let's simulate and use the right pointer here. So at the moment, even though we're running, you can see that the LED is pink rather than white or red, and that means that this wire here is not actually 0 or 1. It's in an indeterminate state because nothing is actually telling it what value it should have. And if we use the logic probe, which we haven't used very often before, you can see that the grey here, as we click on it, means 0 because these wires are 0, but this one doesn't have a value. It's indeterminate. Let's go back to the hand. So let's enable this tri-state buffer here. And as you see immediately, the LED goes to white rather than that faint pink. And this is uh, the thing that's been connected to. So as we hit that up and down, it makes the LED go up and down. So let's disable that one and do as proof the other one. And so if we make changes to here, that's not affecting what's going through. And you see just basically that high stops at the tri-state buffer. And um, this is the one that's active. So there's a great question, which is what happens if I activate both at once? Which then creates that contention. It's called bus contention, when you have two things trying to write to the bus at once, trying to determine what the values of the bus wires are. And if I do that inside the simulator, I get a very quick message that came up and it stopped simulating. You might not have noticed that. Um, so there, let's see if I can do it in such a way that we see that message. There we go, bus contention, process halted. And the simulator detects that this problem of bus contention is happening and it's actually stopped it simulating because it cannot guarantee what's going to happen as a result. So it's easier for it just to say, no, you're not allowed to do that. I'm going to stop you from being able to do that. So the way that this would work in connection with the bus is that you would um, internally inside these bus components, there will be these tri-state buffers which are connected to the bus lines. So when it wants to see it as an output, it enables all of the tri-state buffers. And I'll quickly set up just, is it worth doing two? Let's see, we probably can. Just stretch that along a bit. Right, so I'm going to create a 4-bit, very simple thing, which is going to connect an input to that, and I'm going to duplicate that. So then I've got 4 of them, and then I'm going to add another interactive input, which is going to do all 4 of these enables at once. Why? Come on. It's maybe not the neatest way of doing it. I should have had some more space there. Let's make this a little bit better looking. It's not hugely important. It'd be nice to see that now. Unfortunately, that's going to drag that gate as well. Let's pull that back there. Nah, it's not as neat as I would like, but it's okay. It's not too bad. So that'll be one component, and we're going to make a duplicate of that so that we've got a second. Oh, how much of that have I copied? I've managed to let go of that, unfortunately, so it's that's become problematic. I'm going to have to start deleting stuff. Sorry about this, because it kind of appears on top of itself partly, and then because I deselected, um, it's very hard to reselect those particular bits that I wanted. That one, I don't want. I don't know which one this one is. That's the one I don't want. Bear with me, I'm nearly there, I think. That one shouldn't be. Have another one on top of it. That should be down to the elements that I wanted. I have to be careful not to deselect. So I've got a second set. Hopefully it's all exactly as it should be. And we're going to connect that. I can imagine that's goes down 3 to 0. Let's count these up. So this is not actually making a specific component that we're going to use later. So while I'm doing this to demonstrate how this works, you don't necessarily need to do this yourself unless you want to show for yourself how this works. In the next video, we will actually be applying this and creating a register. So simulation. There we go. It stopped because this bit down here has got bus contention still because I haven't changed the settings. Let's get rid of that. Try again. Directions. So we've got two 4-bit input things here, and I'm going to put the number 10 on this one. And when I hit this, it should enable it to the bus. And this bus happens to have LEDs on one end of the wire. I tend to do that quite commonly so that it's easier to keep track of what's going on. And on this, I'm going to put the binary number 7 instead. And so when I hit that, it sends that to the bus. I haven't got memory and registers to be able to read from the bus, but we're going to expand what we're doing with this in the next video when we actually put this together to create a register. So that's it from me for now.